Hello everyone, this is Dan Gonzalez. Today we're going to be talking a little bit about design of experiments. The purpose of the DOE is to identify factors that actually make a difference and understand interactions and be able to experiment, learn something from the experiment without any guessing, using a systematic approach. So, I'm sure many of us have experimented keeping several factors constant and then changing one factor and then trying to understand what that impact was. That could create a lot of problems and take a lot of time. For example, by doing that, you won't be able to understand if there are any interactions between the factors, right? And additionally, you're probably going to spend a lot of time trying to reproduce information that you already have. So let's go into a little bit of explanation. First off, factors and levels. Levels are the conditions that you are changing, and the factors are the things that you are changing. Here I laid out an example for maximizing car MPG. Here, the factors that I've chosen are tire pressure, and you can see here with the tire pressure I selected 30 and 55 PSI, right? Fuel cost, I've got cheap gas and I've got expensive gas, and then I've got two routes. Let's say you're going to your place of work. One route takes a little more time, but it's flat. Another one takes less time, but there are hills. So we're going to evaluate how we can possibly do that without going through something like several months of changing one variable while keeping everything else the same. So in this case, tire pressure, low with the minus sign, 30 psi, high, 55 psi. Notice the nomenclature for DOE. So I have 8 runs that covers my entire design space. And here I've got my levels and factors. Quick note how to remember this and never forget. Factors fly, that's why it's on top. Levels lie. So if you have 2 levels with 3 factors, you complete the entire design space in 8 trials. So let's take a look at how that looks, or how that works. So if you can imagine, this is a box which encompasses your entire design space. There we go. And in this case, you would be manipulating tire pressure, let's call it TP, and we've got our low tire pressure and our high tire pressure. And then we've got our fuel, let's take this axis for fuel. We have our low fuel, which is cheap gas, versus our high fuel setting, which is the more expensive gas. And then we have our low setting here to back here for flat versus hills. Okay, so that's our route. So now we've defined our entire cube in 3D space, and we can go from low to high, low to high, low to high, forward and backwards. Fantastic. So, DOE will help you increase your process knowledge. It'll help capture interactions which you probably could not capture before Hello, everyone. This is Dan Gonzalez, and today we're going to talk a little bit about design of experiments. All right, so I took a moment to fill up our chart with some results. Our average MPE before we started our experiment was 25 miles per gallon. And here I put in some numbers in a simulation in our design of experiments that shows the results. For example, if you have high tire pressure and you have the more expensive fuel and you take the hilly route, you can expect an increase of 8 mpg. Hi everyone. Today we're going to be exploring design of, oh, it's backwards, isn't it? Okay, we'll see if it's backwards.